Welcome back to our AI training journey. So far, we've covered the what, why, and how of artificial intelligence, machine learning, and deep learning. You now understand the incredible power these technologies wield. But here's the secret sauce that makes it all possible: data. Learning objectives and what we'll master today. In today's episode, Session 4, Data is the New Oil, we're diving into something absolutely essential in the AI world: data. By the end of this session, you should be able to understand why data is foundational to AI and ML, differentiate between structured and unstructured data, learn about the data collection, cleaning, and labeling processes, understand common challenges in working with data, get introduced to essential data sets and tools used in AI projects, and finally, grasp practical pre-processing techniques like handling missing values, dealing with outliers, and splitting data for training and testing. By the end of this session, you'll be equipped with the fundamental skills to transform raw, messy data into a format that your AI models can truly learn from. Why is data so important? You've probably heard the saying, data is the new oil. But what does that actually mean? Just like oil fuels the industrial age, data fuels the AI age. AI systems don't just work out of the box. They need massive amounts of data to learn patterns, make decisions, and get smarter over time. Think of your AI model as a student. If you feed that student inaccurate, inconsistent, or poorly organized information, how well do you expect them to learn? Not very well, right? The same applies to AI. Well-prepared data leads to higher model accuracy. Clean data means fewer errors and more reliable patterns for the model to learn. Faster training. Models can train more efficiently on structured and relevant data. Better generalization. A model trained on diverse and representative data will perform better on new, unseen data in the real world. And reduced bias. Pre-processing can help mitigate some data biases, leading to fairer and more ethical AI systems. In short, data preparation isn't just a step, it's the foundation upon which successful AI models are built. It often consumes the largest portion of an AI project's time, sometimes as much as 70 to 80%. Types of data. There are two main types of data we work with in AI. Structured data. Think rows in Excel spreadsheets or database tables, numbers, categories, clearly labeled fields. It's highly organized and easy for machines to process. Examples include customer names, ages, product prices, or sensor readings. Unstructured data. This is the messy stuff: images, audio recordings, videos, free-form text, social media posts. It doesn't fit neatly into traditional rows and columns. Fun fact, a staggering 80 to 90% of the data generated today is unstructured. This is why deep learning, with its ability to process complex raw data, has become so crucial. The data pipeline: collection, cleaning, labeling, and storage. Before data is used to train models, it typically goes through a series of crucial steps, often called the data pipeline. This usually includes collection. This is where we gather the raw data from various sources: sensors, web applications, user inputs, social media, public data sets, or even manual surveys. Cleaning. This is the first major transformation. This involves identifying and addressing common data quality issues like missing values, outliers, inconsistent formatting, like USA versus U.S.A or different date formats, duplicates, identical rows that can inflate your dataset. Labeling. This is a vital step, especially for supervised learning. It involves tagging your data with the correct outputs. For example, drawing bounding boxes around objects in an image and labeling them cat or dog, or marking text as positive or negative sentiment. Storage. Once cleaned and labeled, the data needs to be organized and stored efficiently in databases, data warehouses, or cloud storage services, making it easily accessible for model training. Feeding to models. Once all these steps are complete, your data is ready to power your AI models. Data challenges in AI. Working with data isn't always glamorous. It comes with its share of challenges. You'll definitely run into issues like bias. If your training data isn't diverse or representative, your AI model will inherit those biases, leading to unfair or inaccurate predictions, especially for underrepresented groups. This is a huge ethical concern. Privacy concerns. In fields like healthcare or finance, handling sensitive personal data requires strict adherence to privacy regulations and ethical guidelines. Missing or incomplete data. As we mentioned during cleaning, significant gaps in your data can make models unreliable or even useless. Data labeling cost. For large datasets, manual labeling is often expensive and time-consuming, requiring human expertise. Essential pre-processing techniques. Beyond the initial cleaning, we perform additional pre-processing to optimize data for our models. 1. Handling missing values. Missing data is a common headache. You have a few options. Removal. If only a few rows or columns have missing data, you might just delete them. But be careful not to lose too much valuable information. Imputation. This involves filling in the missing values. For numerical data, you might use the mean, median, or mode of the column. For categorical data, you might fill with the mode, most frequent category, or a special unknown category. More advanced methods use other ML models to predict missing values. 2. Dealing with outliers. Outliers can skew your model's learning. Identify. You can spot outliers using statistical methods like z-scores or visualizations like box plots. Handle. Sometimes removing them is appropriate if they're clear data entry errors. Other times you might transform the data, example using logarithmic scales to reduce their impact. Or you might use robust models that are less sensitive to outliers. 3. Data transformation and scaling. Many machine learning algorithms perform better when numerical input variables are scaled to a standard range. Normalization, or min-max scaling, scales features to a fixed range, usually 0 to 1. This is useful when you want to preserve the relationships between values but scale them down. Standardization, or z-score normalization, scales features to have a mean of 0 and a standard deviation of 1. This is good when your data has different units or wide ranges. It makes features comparable. Imagine comparing someone's height in meters to their weight in kilograms. Scaling puts them on a level playing field for the model. 4. Encoding categorical data. Machine learning models primarily understand numbers, so if you have text-based categories like red, green, blue, you need to convert them. 1. One-hot encoding creates new binary columns for each category. For example, red becomes a column with a 1, and green and blue columns have zeros. This is great for nominal categories where there's no inherent order. Label encoding assigns a unique integer to each category. Red might be 0, green 1, blue 2. Use this carefully as it might imply an artificial order to the model. Tools and datasets to explore. Ready to get your hands dirty? Here are a few awesome open datasets to get you started and some fundamental tools. 1. MNIST, a classic, a dataset of handwritten digits perfect for beginners to train their first image classification model. COCO, Common Objects in Context, a large-scale image dataset with object detection, segmentation, and captioning annotations, great for computer vision projects. IMDb Reviews, a dataset of movie reviews, excellent for natural language processing tasks like sentiment analysis. Kaggle, this is your gold mine. It's an online platform for data science and machine learning competitions, offering thousands of datasets, code examples, and a vibrant community. And for the tools, you'll want to check out Pandas, a powerful Python library for data manipulation and analysis, your best friend for data wrangling. NumPy, another foundational Python library for numerical computing, essential for working with arrays and matrices. Labelbox, or CVAT. If you need to label your own image or video data, these are popular tools for annotation. Google Colab, a fantastic free cloud-based Jupyter notebook environment. You can write and execute Python code with free access to GPUs, perfect for quick testing and learning without powerful hardware. Data splitting, training and testing. essential for evaluation. Finally, once your data is clean and pre-processed, a critical step is to split your data set. Why? Because we need to evaluate how well our model performs on data it has never seen before. We typically split our data into two main sets. The training set, example 70 to 80% of data. This is the bulk of your data. Your AI model will learn from this data, adjusting its internal parameters to find patterns. Test set, example 20 to 30% of data. This portion is held out and not shown to the model during training. Once the model is trained, we use the test set to evaluate its real-world performance. This gives us an unbiased estimate of how well our model will generalize. This split helps prevent overfitting, a common problem where a model learns the training data too well, memorizing it rather than understanding underlying patterns, and thus performs poorly on new data.
Wrap up and what's next? Today, we learned why good data means good AI. We covered the types of data, the data pipeline, common challenges, essential pre-processing techniques, and powerful tools and data sets to get you started. This session is incredibly practical, so I encourage you to revisit it as you start working with your own data sets. In the next session, we'll finally get to the exciting part, building your first machine learning model. We'll put all this data knowledge to good use and see an algorithm in action. So if you're excited to build your own AI, make sure you don't miss it. Don't forget to like, comment, and subscribe to keep up with our AI learning journey. Your engagement truly helps the channel grow. Here is a recap of what we learned today. Data is the fuel for AI ML. Structured versus unstructured data. Data pipeline. Collection, cleaning, labeling, storage. Challenges, bias, privacy, missing data, labeling cost. Key pre-processing, handling missing values, outliers, scaling, encoding. Split data into training and test sets. Explore MNIST, COCO, Kaggle with Pandas, Colab. Thank you so much for joining me today. I can't wait to see you in the next session where we build our first model.